Good evening, everyone. This evening I'm going to talk about climate change indicators. Climate change indicators can be any phenomenon. We could talk about wildfires, such as those occurring in Canada. We could talk about the loss of sea ice, such as occurring in the Arctic. Or we could talk about biodiversity problems that are occurring in our oceans. But today I'm going to talk about sea level changes. That is a topic that has been the center of my research for nearly 20 years. Now, climate change indicators may be a more effective platform to try and convince to you that we must have urgent action on climate change. As a group of academics, we've come together in a variety of reports. The National Academy of Sciences states that the changes observed over the last several decades are due to human activities. The American Association for the Advancement of Science states that global warming is not a theory anymore, it's a fact based upon the observations that we see in front of our very eyes. The predictions made on climate in the 1990s, due to an increase in concentration of greenhouse gases, are matched by our observed changes. We can take ourselves beyond the United States and go internationally. The Intergovernmental Panel on Climate Change, the IPCC, sponsored by the United Nations, states that the warming of our climate is unequivocal, stating further that there is a very high confidence that the effect of human activity since the 1750s has been one of warming. We can move beyond the academic realm and we can look into industry. There are a variety of industrial reports regarding climate change. This is Munich RE, looking at the frequency of weather-related events. This graphic showing the changes from 1980 to 2010. You see this upward rising trend. In the report, they state that climate-driven changes are already evident. And in the content of North America, it's rising faster than anywhere on our planet. But despite these academic reports, despite information from industry, our emissions of greenhouse gases go unabated. This graphic looks at greenhouse gas emissions divided into 5-year bins. By the year 2010, we emitted nearly 50,000 million metric tons of carbon dioxide into our atmosphere, with the greatest polluter being our energy sector. And within the academic community, we are very concerned about these concentrations of greenhouse gases. Why? Because we know as a community that there is a very strong correlation between temperature and carbon dioxide values. The top graphic shows the changes in temperature for our Earth for the past 700,000 years. In the bottom graphic is the concentration of carbon dioxide. This information is derived from ice cores in Antarctica. You can clearly see that when CO2 goes up, the temperature of our planet goes up. When CO2 goes down, the temperature of our planet goes down. I annotated this figure to show you what the current levels of carbon dioxide are. In the years 2015 and 2016, we recorded levels of 400 parts per million by volume, a full 120 units greater than anything we've seen for 700,000 years. And the rate of increase has not been seen for 66 million years. Now, we're already seeing the effects of these increasing greenhouse gas concentrations. This graphic shows the climate indicator of temperature, showing temperature changes in the 20th and the 21st century. We have been warming up decade upon decade, a 2 degrees C Fahrenheit net change from 1901 to 2013. As well as our atmosphere changes, our oceans are changing. This map shows sea surface changes from 1901 to 2012. There are areas of our oceans that have warmed up by a colossal 4 degrees Fahrenheit. Now, there are many implications of this, but one implication is sea level. When you warm up water, the water molecules occupy a greater space and sea level rises. This is known as thermal expansion. The other major contributor to sea level is a mass change. Water that was previously locked up in ice melts and through the hydrological cycle ends up in our ocean basins and sea level rises. You can see this dramatically in photographs. This is a photograph of the Muir Glacier in the 1940s and the 21st century. But it isn't only in Alaska that our glaciers are retreating. The graphic shows the relationship of all glaciers. Since 1960, 2,000 cubic miles of water have been lost. That has implications on irrigation and domestic use. You see the droughts in California. It influences mountain recreation, influences animal and plants, and eventually causes sea level to rise. But when we think about the 21st century, mountain glaciers are not going to contribute very much because there quite simply isn't much of this ice left. But we have two large ice reservoirs. Greenland. Greenland covers some 600,000 square miles. Greenland has the potential to raise sea levels approximately 6 meters or 20 feet. And we have very worrying signs. On the right-hand side, you see a map of Greenland showing how many days are causing warming against the long-term average. You see that it is shaded red. The ice sheet is diminishing in size, but it's also causing meltwater pools. These meltwater pools that exist on the surface are migrating through gravity to the base of the Greenland ice sheet, lubricating this ice sheet so it moves at a faster and faster pace towards our oceans. The graphic shows the result. We have a mass balance problem. Every single year, Greenland is losing more and more mass, and sea levels are rising. But Greenland isn't as big as Antarctica. Antarctica is colossal. It covers some 5 million square miles. It has enough water within it to raise global sea level 65 meters, 200 feet. And parts of this ice sheet are collapsing. The classic example is Larsen B. This was an ice shelf that was stable for up to 12,000 years. But as these satellite images show you, it collapsed within 36 days. The size of Rhode Island, and with a thickness of 220 meters. So the warming ocean and the melting ice cause sea level to rise. At Rutgers University, we analyze the instrumental records. The top graphic shows how sea level has been rising year upon year. But the bottom graph shows the rates of rise. In the 1900s, it was rising at around 1 millimeter per year. By the year 2000, it was rising at 2 millimeters per year. And in the present day, it is rising at 3 millimeters per year. But you may ask yourselves, well, how unusual is this? Well, we're also fortunate at Rutgers University that we can trace back sea level over 10,000 years. Now, this is a period in the Earth's history known as the Holocene. It's when the Earth's climate warmed up from the last ice age. As the Earth warmed up, your oceans expanded and your ice sheets melted. And that meant over the last 10,000 years, sea levels in New Jersey went up 25 meters or 80 feet. On your graphic on the right-hand side shows the rates of change. In the early part of that record, let's say from 10,000 years to 4,000 years, the rates were somewhere in the order of 3 to 6 millimeters per year. From 4,000 years to present, they were much slower, at around 1 millimeter per year. Again, I annotated this figure with what is the current rate recorded by the Atlantic City tide gauge. It records 4 millimeters per year. We haven't seen those rates for many thousands of years on the New Jersey coastline. But if we know the rates of change and we know the absolute values of sea level, we can do something further. We can construct maps of what our coastline looked like in the past. This is a graphic showing the mid-Atlantic shoreline 10,000 years ago. In the black shows the present-day shoreline. I hope you can see Chesapeake Bay, Delaware Bay, the Jersey Shore, Long Island, the Cape. The shoreline 10,000 years ago is at the boundary between the green and the turquoise. Increasing shades of blue are increasing depths below sea level. The greens, the yellows, oranges, and reds are elevations above sea level. 10,000 years ago, sea level was 80 feet below present, and therefore our shorelines was many miles out to sea. But what do you think happened when sea level rose? Well, it eroded our shorelines because sea level encroached landward. It created an island off the Cape. But that island didn't last very long. It was eroded, it was submerged, it was lost. Tens of meters of coastline are being lost every year because sea level's rising at rates that we're going to experience for the remainder of the 21st century. But as we move through to the present, sea level slows. And barrier islands form, the islands that we work, we live, and we recreate on. Our marshes form and our coral reefs expand, the breeding grounds of fish, birds, and other wildlife. And we can put that all together as a context. This graphic shows the magnitude of sea level changes per century over the last 2,000 years, a time period known as the Common Era. You can see how unusual our time is. The changes in the 20th century are an order of magnitude than any century that we've seen over the last 2,000 years. And that is a very powerful statement on climate change. Powerful enough, and I was very humbled and shocked by this, that President Obama used our research in his State of the Union address in 2015, stating that our oceans are rising at any point in the last 2,000 years. So our work has important policy implications, but we can also illustrate that it's already had dramatic impacts on New Jersey and New York City. This graphic here shows the change in sea level from the 1780s towards the present day. You can see quite clearly sea level has risen by around 0.5 meter. I also placed the timing of landfalling hurricanes. We have Irene and Sandy, 2011 and 2012. Its predecessors, Hurricane Donna in 1960, and historic hurricanes in 1893, 1821, and 1788. Sea level accentuates the impact of a storm surge, meaning that it gets to a greater height and it has more power. Sea level rise in the 20th century alone caused 40,000 people in New Jersey an additional 25 square miles to be flooded, to be inundated, to be impacted, that would not have occurred if sea level had not been rising. Hurricane Sandy, lives were lost. Huge economic damage, over $60 billion. It plunged lower Manhattan into darkness. As we move through the 21st century, our Earth is going to warm. It may see more storms like Sandy, but one thing is certain: sea level will rise. So to summarize, I've tried to illustrate you what we know about climate change. I hope that you will think that this is an item that needs urgent action. And sea level is a very important barometer of climate change. Well, why? Well, we live along the coastline, 29% of the US population, 5 of the 10 largest cities. We work along the coastline, 45% of the GDP. What I'd like to leave you with is one last anecdote and then a question for you to ponder as you go home this evening. This graphic shows how simple, at a first order, the relationship is between temperature and sea level. All these dots are time periods in geological history where we know what temperature was and we know what sea level was. 20,000 years ago, we're locked in an ice age. But the Earth warmed. The Earth warmed by around 5 degrees centigrade. It caused 2/3 of the ice on our planet to melt. raising global sea levels 120 meters, nearly 400 feet. Now, if we do nothing about climate change, we are locking ourselves to a further 5-degree sea rise by 2100. We still have a third of the ice on our planet, over 200 feet. How much do you think will rise, and how much as a society can we afford? Climate change is about the young generation. You must make society act on climate. Thank you very much.